Welcome to the AI Research Roundup. I am Alex, your host. Today is May 7th, 2025. Alright, we are looking at a research paper from Hugging Face's trending list, published about 11 days ago, on April 26th, titled Selecting Optimal Candidate Profiles in Adversarial Environments Using Conjoint Analysis and Machine Learning. This paper tackles finding ideal political candidate profiles using conjoint analysis. That is a method where people assess hypothetical candidates with various traits. Since many trait combinations exist, they propose an optimal stochastic intervention, basically a smart probability mix of candidate features, to maximize success, especially in competitive elections. Okay, so this first figure we are looking at, from page 4, visualizes a common starting point, an analysis using average marginal component effects, or AMCE. Average marginal component effects. Well, they estimate how much a single characteristic of a candidate, say their party affiliation or a specific policy position, changes their chances of being selected by a voter when you look at that characteristic in isolation. The plot shows these effects for many different attributes. This traditional view is what the paper argues misses the full picture of strategic competition. All right, building on that idea of needing a more strategic view than just average marginal component effects, this next figure from page 18 displays optimal strategies in the average case setting. You see various candidate attributes plotted, like their sex, age, race, and policy stances. The colored dots, black, blue, red, and green, show the suggested ideal probability for each feature, optimized for all voters, or specifically for Democrats, Republicans, or independents. This visualizes that optimal stochastic intervention, a strategic mix of traits, illustrating how ideal profiles can differ significantly depending on the target audience. Okay, so now we are looking at a more complex scenario. This figure from page 19 dives into optimal strategies in an adversarial setting. An adversarial setting, well, that is where opponents are actively trying to outmaneuver each other, like in a real election. Here, the blue and red markers represent the equilibrium strategy, which is the best set of choices an agent or candidate can make when their opponent is also making their best choices, specifically for an agent facing Democratic voters in blue and Republican voters in red during a primary. It really highlights how different the ideal candidate profiles become under competitive pressure. So, building on how strategies adapt in competitive adversarial settings, where parties are often in what is called a zero-sum game, meaning one's gain in vote share is another's loss. This figure from page 21 really underscores the realism of that approach. It plots historical winning two-party vote shares since 1976 as black dots. The gray stars on the right show model predictions. A simpler model predicts around 0.7, while the adversarial model, which considers this competitive dynamic, predicts around 0.5, much closer to actual close election outcomes we have seen historically. Okay, to further test which approach is more realistic, this table from page 23 compares how well actual 2016 presidential primary candidates fit these different strategies. The authors state that actual candidate profiles show significantly higher mean log probabilities under the adversarial strategies. Mean log probability. Well, that is a score indicating how well a model's ideal profile matches real candidates. A less negative score, so closer to 0, means a better fit. For Republican candidates, their profiles did align better with the adversarial strategy, scoring -15.77 versus -15.87 for the simpler average case. For Democrats, the table shows -16.77 for the adversarial strategy, and -16.18 for the average case. Alright, so to really clarify the differences between various analytical methods, this next table from page 24 compares them. It lines up the traditional average marginal component effect, or AMCE, the average marginal interaction effect, or AMIE, which considers combinations of attributes, alongside the average case and the adversarial optimal stochastic intervention methods. The table contrasts them on factors like whether they need a baseline factor category. That is a kind of default for comparison. Most importantly, the last row shows that only the adversarial approach is deemed, quote, informative about actual optimal strategic choices. So to bring all these points together, the main message is about a smarter way to use conjoint analysis for understanding elections. Conjoint analysis, remember, is that method where voters pick between candidate profiles with different features. The big takeaway is that by treating elections as an adversarial game, where parties strategically compete, the analytical results become much more true to life. Predicted vote shares, for example, better match historical results, and real candidate strategies align more closely with these competitive models. This truly offers a more robust understanding of electoral dynamics. Thanks for tuning into the AI Research Roundup. I am Alex.